Welcome to our class. The topic to treat today is text summarization using fine-tuned predefined model. Text summarization is a natural language processing technique that reduces or shortens long text to enable a reader to understand the context of the text without having to read the entire text. There are two types of text summarization, which includes extractive text summarization. This simply selects the important sentences based on sentence cause. There is also abstractive summarization, which generates entirely new sentences that represent the contents of the text. The purpose for this project is to enable readers be able to read long documents without actually reading them. So the text we are trying to execute here will summarize long documents for readers because there's so many information available online that is becoming cumbersome for readers. So with this project, the readers will be able to understand and read documents as much as possible. This project will utilize the predefined transformer models, fine-tune them to generate abstractive summaries. To commence this project, there are certain requirements that are needed. First of all, you need to have a laptop that has a GPU of at least 16 GB. A laptop without GPU will not be able to undertake this task. Other requirements, software requirements, includes our development platform, which is the Jupyter Notebook. It's advised you subscribe to Google Colab Pro account because it has a inbuilt GPU for that subscription level. Other requirements include the skills. You need to be have a sufficient background in Python or the R language. The data set we are going to use for this project is the CNN Daily Mail 3.0 data set. This is a popular data set that is used for text summarization because it has an already standard human summary, which we can use this to compare with our predefined and fine-tuned summary. There are certain processes we need to undertake to carry out this project, which is the methodology. This includes preparation of the data, selection of the predefined model, fine-tuning the model, evaluating the model, and deploying the model. So we're going to take this methodology, the steps one after the other. The first step is data preparation. To first of all have to install the library, the required library transformer, and the data set. This library is where we'll get our data set, the CNN Daily Mail data sets. So you use this code to get the data sets, then you pre-process the data sets. This involves tokenization, converting the data set to tokens and indices. The next step is you import the model. You select the predefined model. In this case, we're using the T5 small from the auto model for sequence to sequence class of the Hugging Face transformer. This T5 is not really the best, but for demonstration's sake, there are better models like T5 base and T5 large or the BAT. So after selecting the predefined model, we are going to fine-tune the model. Fine-tuning the model, it means configuration on data collection and that entails configuring the hyperparameters such as all the ones we have here, the number of epochs, maximum underscore step, login steps. One thing important here is this maximum underscore step must be set because this is a very small task. If you did not set this maximum underscore step, the training will take a very long time and to be frustrating and it might not finish. So we set, for the demonstration purpose, we set this maximum step to a minimum number. In this case, I set it at 5,000. So there's another class here, the data collector class, which prepares the batches of the data set and make it available for training. So the next step is to train the model. In this case, we are going to import another Hugging Face transformer class, which is the sequence-to-sequence trainer. This sequence-to-sequence trainer will be instantiated with a model. This is where we'll put our model in the argument and the data set, the train data set, and the validation data set. In this step, we call the train function to start the model training. The next step is evaluation of our model. We use the rogue score. There is rogue 1 for which checks overlap of single words. We have rogue 2 diagram that checks overlap of pair of words, and rogue L, which checks the longest sentence of words. To carry out this evaluation, you need to import and install the evaluate library and the row score library. And also you define a function. And one thing again that is important is you have to reinstantiate the trainer, which is the sequence-to-sequence trainer. The purpose of reinstantiating the trainer is to be able to add this compute underscore metric function here, which is our function that we have defined here. So that's the purpose we have to reinstantiate this trainer. After that, we call the trainer to evaluate the model. So we also deploy the model to actually generate the summary. So in this case, we import the pipeline. The pipeline function is part of the transformer library and is used for purposes like this text summarization. So the pipeline accepts the fine-tuned model as argument and pre-process the CNN element dataset to generate the summary. The table here is the result of our task. This table, this column represents the human standard summary that is originally present in the dataset. This fine-tuned model summary is the one generated by our model. So looking at it, you can see that the model did a good job. So to check the performance of the model, we'll evaluate the row score. We have the row score of 0.25, row 2, 0.12, and 0.20. All these indicate that the fine-tuned model showed the ability to generate summaries that overlap with the original human summary. The model did not come with there are limitations. Like, for instance, the T5 small that we use is not really suitable for such a large size data set. But for demonstration sake, we'll have to use that. So if we use the larger models like T5 base, T5 large, or the BAT, I'm sure the results produced by the robe will be better. The number of epochs that we use is also small, so it will not train suitably for such a large data set. And another limitation is the number of steps that we set. This was just for demonstration purposes, for as the data set will train better, increasing the steps. So this is all we have today. Thank you.